Good morning, good afternoon, good evening. We are going through the solutions for chapter 15 exercises. So we wanted to know 20 more than the number is 59. 20 more than the number is 25, not 59, 25. 29, 25, okay. 29 if you do it this way, this should have been 25 if you do it that way. Exercise 2, we wanted to translate the difference between twice the number and 93. Difference means subtract, twice the number 2x and 93. Difference, first number minus second number. Now, twice the difference between a number and 93. The difference between a number and 93, the difference between a number and 93, and twice everything that belongs to this difference. Therefore, parentheses. Did you put in parentheses? Yes? Good for you. 7 more than the product of the number and 8. 7 more than product, multiplication, of the number and the number minus 8. Okay? 7 more than the product of the number and 8 subtracted from the number, or 8 less than the number, 8 less than the number. The sum of 10 and the number is equal to the quotient of 5 and the number. The sum of the number and 10 is equal to the quotient, the division, of 5 and the number. Get that? And 11 subtracted from twice the number is equal to the sum of 3 and the number. So 11 subtracted from twice the number is equal to the sum of the number and 3. So 2x minus 11 is equal to x plus 3. We were not asked to solve, we were asked to just translate. The price of a bicycle is reduced by 1/12 of that price. Let P be the price. 1/12 of the price is 1/12 times P. Reduced means you subtract, so you get the price minus 1/12 of the price. You could also write this as P minus P over 12. You pay $16 for every $100 of the $6,000 you borrow. How much do you have to pay for just borrowing? Okay. We pay $16 for every 100 of the 6,000. As a fraction, it's 16 over 100 times 6,000. Divide by 100, divide by 100. You get 60 times 9. 6 times 96 times 16 is 96 with another 0, because you still multiply by 10, so 960. 960. I did not give you the 960, oh well. I guess the idea was just to translate, not to work it out. Too bad, we missed a good opportunity for a workout. Okay, you go and work out, okay? Evaluate 2a plus b minus 3c if a is 6, b is 7, and c is 8. I came out with 19 plus 24 plus 40, no, that's equal to 43. This is 19, then plus 24, so that equal sign is okay. 19 plus 24 is 43. Remember that minus a negative number is equivalent to plus the opposite, so plus a positive number. We wanted to evaluate x squared minus 2xy plus y squared over 3x plus y when x was 2 and y was negative 6. I came out with the denominator which is 0, the numerator 4 plus 24 plus 36 is immaterial. So if the denominator is 0, I'm in trouble. This function, this fraction is undefined. Then Your spouse buys D pounds of dates at $4.29 each pound, E cartons of eggs at $3.19 per carton, and F pounds of figs at $8.39 per pound. Write an expression for the cost. 4.29 times D plus 3.19 times E plus 8.39 times F. And if you buy 2.5 pounds of dates, that becomes 2.5. You buy 3 cartons of eggs, that becomes 3. And you buy 1 pound of figs, that becomes 1. Now, we didn't want to get the exact number, we wanted to approximate. That's about 4, that's about 3, a little bit low. That's about 8 times 1 over here, and that's about 3 times 3. So when you crank this out, my estimate is about 29, which is probably a little low, and the exact value is $28.69. So it wasn't that low, it wasn't that bad an estimate. But remember, it's just an estimate. 2 different people can come up with 2 different estimates but be close to each other. Okay, that was for chapter 15. In chapter 16, we wanted to solve x plus 9, which is 12. Subtract 3 from both sides, you get x equals 12. You wanted to solve x minus 4, which is 12. Add 4 to both sides, you get x, which is 16. You're not copying this, you're just checking your answers, so I can go a little faster. You wanted to solve. Solve means you have an equal sign, so you can find out what x is. If you didn't have an equal sign, you could say simplify, and you would not say solve. And you could not say x is some number. So solve, subtract 1550 from both sides, you get x, which is 8.25. Solve x minus 1 over 4, which is 0.75. Rewrite the 1 over 4 as 0.25 and add 0.25 to both sides. You get x, which is equal to 1. Solve x minus 4 and 5/12, which is equal to 7 and 4 over 21. Add 4 plus 15 over 12 to both sides. You have convert this to an improper fraction, which looks like, is that what I did? Oh, no, not quite. I added whole numbers to whole numbers, that was 11. I add fraction to fraction. I have 4 over 29, 4 over 21, multiplied by 4 over 4, the denominator is 84. Here, multiplied by 7 over 7, the denominator is 84. The numerator is 16 plus 35, which is 51 over 84. So x is 51 over 84. Another way you could have done that, you know that the least common denominator is 84. So why don't you multiply? I forgot what the example was. I think this was the example. When you start, why not multiply through by 84? And maybe convert this to a mixed number, this to a mixed number, multiply by 84. Reduce, you're rid of all the fractions. You can rework this problem without fractions. Try it that way. See if you can do it. And congratulate yourselves if you're successful. So when we have fractions, there's a quick way to get rid of all the fractions. Multiply by a common denominator of all the fractions, preferably the least common denominator. You want to check yourselves? Check yourselves. Solve x plus 22 plus 53, which is x plus 66. The x's drop out. 55 is not equal to 66. No solution. x is 11 is false. No matter what you do to x, that remains a false statement. Here, on the other hand, you have 55 on the left and the right. The left is x plus 55. The right is the same x plus 55. No matter what you plug in for x, you have a solution. There are infinitely many solutions here. In 17, we wanted to solve 12x equals 12. Divide both sides by 12. You get x which is equal to 1. Solve 1 over 2x minus 5, which is 21. Add 5 to both sides. Multiply by 2. You get x, which apparently is equal to 52. Okay? And then you wanted to solve 34.2 equals 3 over 4x. You divide by 3 over 4, which means you multiply by the reciprocal 4 over 3. And you come out with x, which is 45.6. And then I guess if two letters are next to each other, the values in these boxes are multiplied. If they are not letters, if there are two numbers, you have to sign in between, like a cross, which means multiplication. Although if you write your x's that way, that's not a good sign. If you write your x in script form like that, you can distinguish between these two x's. You can use parentheses around the 2 and the 3. That means multiplication, like here. This is subtraction. This is, you subtract a negative number. And this is, you multiply negative 7 by negative 7. That's the meaning of the parentheses around the negative 7 here. Okay. You want to solve 3 over 5x, which is 0.6. You could multiply both sides by 5 over 3, which is what I did here. And x comes out to be exactly exactly 1. Yes, because this is 0.6 times x, this is 0.6. Divide both sides by 0.6, you get 1. Solve 2 and 4 15ths x, which is 1 and 7 over 20. I converted the 2 and 4 over 15 to an improper fraction, this to an improper fraction. I needed a common denominator. Oh, I am multiplying by the reciprocal, so I'm multiplying both sides by 15 over 34. I can reduce, and my answer is 81 over 136. Did you get that answer? Then a total of 10 adults and some children went to a concert. The admission of an adult was $12.50 and that of a child $5.22. And I said a total of 10 adults and children, or a total of 10 adults and some children. So that could be misinterpreted, and you could do it in two ways and be correct. The way I did it, yeah, that's about it. A total of 10 adults and no children. That would cost you a total of $125. We had $92, so that's not the combination that I'm looking for. If you had 9 adults and 1 child for a total of 10 people attending the concert, you would have to pay for the adults this much, the children this much, $116.75. 8 adults and 2 children, $108.50. 7 adults and 3 children, $100.25. And finally, 6 adults and 4 children. This is the number you were looking for, 92. So how many adults and how many children can go with a budget of 92? 6 adults and for children. Is there a magic way of solving this? Yes, there is. Let x be the number of adults, then 10 minus x is the number of children. You may or may not understand this. The total is 10. And when you multiply x by 1250 and you multiply 425 by all of 10 minus x, you're supposed to come out with $92. So you want to solve this equation. You want to solve this equation. And you should come up with x which is equal to 6. And then the children will be 10 minus 6 or 4. So yes, you can do this algebraically. Okay. I've done it by pure guessing up there in the table. This is the correct way that we should be doing it. I think the other one was useful. You got a flavor of how to get to this, I hope. In problem 7, what value of the unknown, what value of x will make this fraction undefined? Well, what fraction will make the denominator 0? 2x plus 6 is 0, or x is negative 3 over 2. I am back, and we are ready to do chapter 18 in my book. I remind you that you can get a PDF of this. Now, chapter 19 corresponds to Introduction to Ratios in the textbook, and chapter 20 will be solving proportions. So let's do the basics. At Coastline Community College in Orange County, California, about one student born in the Pacific Islands is out of 100 students. So out of 100 students, one of those will be born in the Pacific Islands. That comes from the census. And the ratio would be 1 student to 100 students, 1 student in the Pacific to 100 of all students, which is written as 100 to 1, which is written as 100:1, which is written as a fraction 1 to 100. In my opinion, the fraction is the most useful. So that's easier to work with. Another comparison, if the units are different, the term used is rate. So ratio and rate. In rate, you have units that are different. In ratio, you have units that are the same, like dollars over dollars, or cents over cents, or even dollars over cents. You can make them the same units. So it's a matter of terminology. If you mix the two, rate and ratio, it's not the end of the world. So a rate, 130 miles per 2 hours. Or if you reduce that, 65 miles per hour. Where have you heard that before, 65 miles per hour? Oh, amazing, 65 miles per hour rate, the speed. Wow. Now, if the denominator is 1, like 1 hour, I don't need to write it, miles per hour, you have a unit rate, 1 unit, 1 of whatever is in the denominator. So we have ratio, we have rate, and we have unit rate. Some examples. Are the ratios 6 to 13 and 30 to 65 equivalent? Let's see if we compare the fractions. Is 6 over 13 equal to 30 over 65? 30 over 65. You are taught to cross multiply 6 times 65 and 13 times 30. 6 times 65, is that equal to 13 times 30? This becomes 390, that becomes 390, yes. So these two fractions are indeed equivalent. Why does cross multiply work? Somebody tells you cross multiply and you follow blindly? Somebody tells you jump off a bridge and you jump off a bridge? I hope not. Let's see if I can convince you that it works. You had 6 over 13. multiply by 65 times 13, the product of the denominators, not necessarily the least common denominator, just the product. And on this side, also multiply by 65 times 13. You can reduce this, the 13 over 13 is 1. You can reduce this, the 65 over 65 is 1. You are left with 6 times 65, which is equal to 30 times 13. The two fractions are equal. The denominators dropped out. You are left with what we consider cross product. You could also have tried to reduce that, and if you reduce that, you divide by 5, and you get 6 over 13. So there you definitely see that the two fractions are equivalent. They're exactly the same. This reducing does not always work. Cross multiplication always works. How about the ratio of 4 hours to 20 minutes? Is the term ratio correct, or could it be a rate? Are these two units the same? Not yet, but we can make them the same. Because if I divide by 4 over 4, which is 1, I get 1 hour, I get 30 minutes. So you have 1 hour per 30 minutes. And 1 hour is the same as 60 minutes. Now the units are the same. The term ratio is applicable. And that gives you 2 to 1. So 4 hours is to 120 minutes, as 2 is to 1. You want to look at that for a little bit? Okay, can I go on? Simplify 615 miles per 30 gallons of gas. What is the unit rate? Rate, the units are different. Can you reduce this? You can. You can divide by 5. You can divide by 3. You can divide by 15. You cannot divide by 2. Okay. So we have divided by 5. 5 apparently goes into 615 123 times. So that's the same as 123 miles per 6 gallons of gas. Make it a unit rate. You can still divide by 3, as I said earlier, so you get 41 miles per every 2 gallons of gas. How about 1 gallon of gas? How many miles? Divide the denominator by 2, divide the numerator by 2, that's 20.5, 20 and 1/2 miles per gallon. That's about average for a rather poor car, poor gas mileage car. They tell you can get 30 or 40 or 50 miles per gallon. Maybe, maybe not. Maybe not. Do not turn the improper fraction into a mixed number. Do not turn this into a mixed number. Why not? Why not? Why couldn't you say 20.25 miles per gallon? I don't understand the statement that I made here. I don't remember what my reasoning was, and I certainly don't see it now. Okay. Your spouse asks you to get a painkiller on your way home. You are considering one of the products below, and you wonder which one is the cheaper. Okay? You want to know whatever's cheap. You don't care if it's a good product or not. You can get CVS Pain Relief Tablets, extra strength size 50 tablets for $5.29. I got that from a commercial. You can get CVS Pain Relief Rapid Release Gel Caps, extra strength, size 100 tablets for $7.99. And you can get CVS pain relief tablets, extra strength size 60 caplets or 60 tablets at $5.49. How can you compare this? Which is the cheaper? Is it the $5.29? That's a lower number. Which is the higher one? Is it this one? That's a higher number? Not necessarily. You don't have the same number of units, the same number of caplets or caplets. If you knew the price per each caplet or tablet, you could compare them sensibly. So you have $5.29 per 50 caplets. Divide numerator and denominator by 50. The denominator is $0.1058 or 10.58 cents. Okay, a little bit more than 10 cents. If you take the second one, you get $7.99 divided by 100 caplets. That's very easy when you divide by 100. All you do is move the decimal point 2 places to the left. That gives you 7.99 or practically 8 cents per caplet. So 10 cents here, 8 cents here. That one is cheaper when I compare these two. And 5.49 divided by 60, which apparently is $0.0915 or 9.15 cents, 9 cents. So now which is the cheaper? I have 10 cents, I have 8 cents, and I have 9 cents. This is the cheaper one. The $7, the more expensive container, is the cheaper one per unit. Isn't that amazing? Money-wise, that's what I just told you. How fast is 60 miles per hour? I know it's fast, but I have no idea how fast is. When a car goes by, zoom. How about zoom with a zoom? How fast is fast? They're both fast. If I could convert 60 miles per hour to feet per second, I can gauge 1 second. Boom, that's 1 second. 1001, that's 1 second. From start to saying 1000 to the end of 1, that's supposed to be 1 second. 1001. In that short amount of time, you can go what distance, how many feet? Well, if I have a certain number of feet, I can gauge it. I'm in a room that has, let's say, 30 feet. So if I go from this wall to the other wall and it's 30 feet, I know how far 30 feet is. I can look and see. But 60 miles per hour? So my object is to convert 60 miles per hour, 60 miles per hour, a fraction, 60 in the numerator, and 1 hour, 1 in the denominator. Convert that to feet per second. I need to know that there are 5,280 feet in 1 mile. The British system is all crazy with units. I need to know that there are 60 minutes in 1 hour and 60 seconds in 1 minute. If you don't know the last two, 60 minutes per hour and 60 seconds per minute, I wonder where you have been. You start with 60 miles per hour. You multiply miles per hour by 1 hour over 60 minutes. There is 1 hour per 60 minutes. There is 1 hour per 60 minutes. The minutes, the hours are in the numerator because you want to get hours over hours. That drops out. That's like 7 over 7. That's 1. So you have to multiply or divide by 60. If you put the units correctly and you know what unit 60 goes with minutes, so 60 is in the denominator. And then you want to get rid of minutes, you multiply by minutes per second. There is 1 minute per 60 seconds. The hours dropped out, the minutes dropped out, you're left by seconds. Miles. You are told that there are 5,280 feet per mile. Mile needs to be in the denominator because over here it is in the numerator. So miles drop out, you are left with feet. Your units now are feet per second. You did this correctly as far as the units are concerned. Now do the math. 60 over 60 is 1. 5,280 over 60, divide by 10, then divide by 2, then divide by 3. So 60 goes into 5,280 exactly 88 times. So 60 miles per hour is 88 feet per second. If from that wall to this wall is 30 feet, 3 times the distance from this wall to that wall is covered in 1 second. Isn't that, oh, that is incredibly fast. Would you want to go and stand in front of the car that comes to you at 60 miles per hour? You would be thrown from 3 times that wall to this wall in 1 second. In the time you could say 1001. How much of you would be left? I think they would be picking up the pieces. How can you measure how far it is from this wall to that wall? Why don't you walk at your regular stride? Okay, like you go for a walk. Doesn't matter how fast you walk, but count the number of steps. 1, 2, 3, 4, and each time you take a step, my estimate is you cover about 2 feet. So if you cover a distance of 44 feet, that's approximately 88 feet. If you cover 44 steps, that should be about 44 feet. That's pretty far to get thrown in 1 second. We are ready for the exercises. I think we have a recording today which is only 1 hour, not 2 hours. We have only 2 sections in the book. And I got about 25 minutes left. My first exercise are the ratios 7 to 26 and 42 to 156 equivalent? 7 to 6 and 44 to 156. How about simplifying the ratio? 5 yards. I think that should be called rate, but don't sweat over it. So reduce 5 yards to 240 inches. Well, I suppose I'm saying 5 yards per 240 inches. Per means division also. So how can I do that? What do you need to know? Did you know that in the British system we have 3 yards? No, we have 3 feet per yard, and we have 12 inches per foot. You need to know that to do the conversion. And the word ratio is indeed appropriate here. The units drop out. Then you wanted to simplify $615 for 35 hours. You worked 35 hours, you got paid a total of $615. How much did you make in 1 hour? So how many dollars is it per 1 hour? That would give you a unit rate. Can you simplify this? Yes, you can. I can just look at it and see. Can you look at that and see? How do you recognize dividing by 2? How do you recognize dividing by 3, by 5, by 10, by 6? Your spouse asks you to get toothpaste on your way home. She got over her headache. You are considering one of the products below and wonder which is the cheaper purchase. Could it be the lower priced package? Maybe, maybe not. You want to compare Colgate Total Toothpaste Advanced Whitening, size 5.8 ounces for $4.39 to Colgate Total Toothpaste Advanced Whitening, no zero here, size 7.6 ounces for $4.99. Well, the price is pretty close, but you get more ounces here than here. So I suspect, my hunch is this is the cheaper one. Why don't we do everything per ounce and see? This is an exercise, so the solution is not available here yet. I'll give you the solution next week, next video. We continue with chapter 19 in my book, which says solving proportions. What's a proportion? A proportion is a statement of equality between two ratios or two rates. Equality, there's an equal sign. At Coastline Community College in Orange County, California, you have about 477 Caucasian students out of a total student population of 1,000. The question, so that's a statement, it's not a proportion. I want to use that statement in a proportion. How many Caucasians are at Coastline Community College if the ratio is 447 to 1,000, like I had up here, and there are a total of 11,000 students enrolled at CCC, and round to the nearest 100. So if round to the nearest 100, that's a good enough approximation. I know the answer. There are X number of Caucasian students enrolled at Coastline Community College. Okay? I know the answer to every word problem. And so do you. Then we set up a proportion. 447 Caucasians to 1,000 all students. Same units, Caucasians in the numerator, ex-Caucasians, over a total of 11,000 all students in the denominator. Again, the units must agree. Caucasian in the numerator here and here, all students here and here. Or you could reverse both. You could have all students in the numerator, Caucasians in the denominator. If here you also had all students in the numerator and Caucasians in the denominator. Okay? The units are extremely helpful. Please keep the units. It will help you prevent making mistakes. Without the units, somebody could have written 44 over 1,000 and then switched 11,000 over x. That would not have worked. You want to cross multiply. You get 447 times 11,000, which is x times 1,000. You divide both sides by 1,000. You are left with 11 times 477, which is 5,247, so approximately 5,200 rounded to the nearest 100. So there are about 5,200 out of 11,000 Caucasian students. This is about a half. 447, that's about 500 over 1,000. One half of this is 5,500. Approximately 5,500, a little bit less than that. If that is not right, at least it's a ballpark figure. Okay? So it looks like this is probably the right answer. Well, if it's not the right answer, it's close. Again, the units, the use of units is not only recommended, it is indispensable. It lets you avoid writing mistakes. Like this. Okay? This is wrong. You have Caucasians in the numerator, Caucasians in the denominator. Caucasians should be in the numerator, just like over here. And all students in the denominator here and here, or vice versa for both units. Don't make little of this. Again, units are very, very important. Back to cross multiplication. Why does this work? Well, you can multiply both sides by 11,000 times 1,000. The 1,000 drops out, the 11,000 drops out, and you're left with what would normally be the cross product. We wanted to solve 2.5 over x, which is equal to 5 over 0.9. Here, cross multiplying is not a bad idea. So 5x is equal to 0.9 times 2.5. You could multiply these two or hold off with multiplication. Maybe you can reduce. Divide both sides by 5. Yeah. Do you like working with decimals? Maybe, maybe not. If I get rid of decimals, I multiply by 100 over 100. So one place here, one place here. And the denominator is, the decimal point is 2 places, from 5.00 to 500. And you can reduce. 25 goes in here 20 times. 9 over 20 is about 0.45. So x is about 0.45. Should I leave this so that you can see it for a little bit? Okay, I got 18 minutes left. So this was example 2. I let you look at it for a while. And I'll proceed with example 3. In example 3, we wanted to solve. This is the main fraction bar. It should be longer than it is. This is, as I said, this is the main fraction bar because the equal sign and this fraction bar are at the same level. The numerator is the mixed number 3 and 2/3 divided by 11, which is x over 9. You could convert this to a mixed number. You divide by 11 over 1, so you multiply the, I said mixed number, I meant improper fraction. You multiply the improper fraction by 1 over 11 and then continue with cross multiplying. Let's see if I did it that way. That's the original problem. I converted 3 and 2/3 to 11 over 3. That's 3 times 3, 9, plus 2, 11, 11 over 3. 11 over 3 divided by 11. This is the numerator, which I could multiply by 9. This is the denominator, which I could multiply by x. No, I didn't do it that way. Yes, I did. I multiplied by the reciprocal. So I have 11 over 3 divided by 11 over 1, so multiplied by 1 over 11. I did not multiply both sides. I'm just working with the left side. And this reduces to 1 over 3. So I have x over 9, which is 1 over 3. Do you want to cross multiply? You can if you want to. And if you cross multiply, you get 1 times 9, which is 3 times x. And then you divide by 3, and you get x, which is 3. There we go. Could you also have said that in order to get the same denominator 9, you multiply by 3 over 3, so that gives you 3 over 9. 3 over 9 equals x over 9. The fractions are equal. The denominators are equal. The numerators must be equal. X is equal to 3. Okay, I'll bring it down and let you look at this again. You can copy this if you want to. I'll move it up 1 line. I'll move it up 1 more line. And at this point, x is equal to 3. So in math, there is frequently more than one way to get the answer. Would you agree with the following statement? Every problem has at least two solutions. Like 2 plus 3 is 5 and 2 plus 3 is 6. Those are two solutions. One is the correct solution, one is the incorrect solution. Okay? So every problem has at least two solutions. Not necessarily two correct solutions, but two solutions. All right, you had a good laugh. You can come back and become serious. Estimate the travel budget for a vacation from Los Angeles to San Francisco and back. The one-way distance is 400 miles, and your car is getting 32 miles per gallon, and the cost is $4.50 per gallon of gasoline. Round these numbers to the nearest 10. Nearest 10, not nearest tenth. It's a budget, so you want to make sure you get enough money to do the trip. Write 400 miles as a fraction, so 400 over 1, and multiply the stated rates or their reciprocals to eliminate units. Okay? To find the answer, we want to play with units. We want to have unit over the same unit to make the units drop out, if that is possible. So we have 400 miles over 1, and I'm given how to go from miles to gallons or gallons to mile. There were 32 miles per gallon. Miles are in the numerator, so here miles need to be in the denominator so that the miles drop out. And I'm left with 400 over 32 gallons of gasoline. I didn't have to guess. Do I have to multiply by 32 or divide by 32? The units told me divide by 32. Do you see the usefulness of units? Maybe, maybe not. And then you wanted to go from gallons to dollar. You pay $4.50 per gallon. So you need the gallons in the denominator for the gallons to drop out. You get dollars in the numerator. That's what you wanted. What is the cost? The cost is in dollars. Now your math is 400 divided by 32 multiplied by 4.5, which should give you $56.25. Round to the next higher 10, about $60. So the trip going is about $60. And the trip coming back, I assume, is going to be roughly the same thing. You should budget $120 for the round trip. It's an estimate. Take a little bit more money just in case something is not quite right. Maybe inflation goes up. Maybe the price per gasoline is going to be more expensive. Maybe something happens to your car and you don't get 32 miles per gallon. So play it safe. But you have an idea of what you think you will need. And then we have exercises. How many Caucasians are at adverse city college or community college if the ratio is 56% and there are 15,000 students enrolled? 56%, 56 per 100. Oh, I didn't want to give this away. This is just the exercise. I will not show you the solutions yet. The solutions come in on the next video in a week. Okay, so we have 56 per every 100 Caucasians at adverse college, and there are a total of 15,000 students. How many of these 15,000 students are Caucasians? Can you get an estimate? A little bit more than half of this. Okay? So you should come out with something like 8,000 or so. Then you wanted to solve 5.6 divided by x, which is equal to 8 over 0.9. Will there ever be a case in which you don't get a solution? I guess if x were to come out to be 0, you would be in trouble. Okay, the next exercise. We want to solve 4 over 11, which is equal to x over 8. I wonder what the estimate is. You figure it out. And then we wanted to estimate the travel budget for a vacation from New York to Quebec and back, Quebec and back. The one-way distance is 520 miles. Your car is getting 20 miles per gallon, and the cost of gasoline is $4.39 per gallon of gasoline, and round to the next tens place. Okay, I'll let you copy that, and maybe I'll give you time to think about it. Maybe you can start your thinking. And this is just an estimate. Some people can come up with a number. Other people who do the same computations come up with a slightly different number, which is okay. If you want the exact number, you don't do estimation. Again, I don't want to give you the answer, and I think this is the last example. Yeah, that's the last example. The examples are like, the exercises are like the examples I'm giving you. So make sure you can work out the examples until you can work them without looking back at the solution or without asking anybody or looking at the book. And when you can do the examples that I showed you, then you are ready to do the exercises. And if you get stuck in the exercises, next week you can see where you got stuck, why you got stuck, where we disagree. Maybe you are right and I'm wrong. It's possible. In which case, I would like you to send me an email. Don't call me. It's preferable to communicate by email. Okay. We are about halfway through the course. At the end of Chapter 5, I think we have scheduled the midterm. In preparation for the midterm, you have a midterm review on the website. Go through the midterm review. Make sure you get the answers. You can take the review as often as you wish. So do your best. And all I can say is good luck. We still have about 5 minutes left. I guess we could do gymnastics. I said we were about halfway through. What else do we have planned? Introduction to percent. Percent is a ratio, and we want to solve percent problems. We get more on percent. So we probably have commission. We probably have down payment of a house. We probably have interest. And then we get into something that you don't often see in the beginning algebra, in the beginning basic arithmetic, basic mathematics class, positive and negative numbers. You also probably recognize that this topic is so important that not only should you get introduced to it right now, introduction to negative numbers, and not only get used to it now, but if you understand just a little bit now, you have a better chance of understanding it in your next course. And I show you different ways of thinking of positive and negative numbers. Negative numbers and positive numbers and manipulation of that kind of number is extremely important. It is so important that I'm going to make a statement that may scare you. If you don't get a hold of working, multiplying, adding, subtracting, and dividing by positive and negative numbers, this may be the end of your scientific career. Okay? Positive and negative numbers and operations of those numbers operations are extremely crucial. Don't take it lightly. Another thing that is crucial, chapter 2, working with fractions. If you get nothing else out of this besides a good solid foundation on fractions and mixed numbers, and a good solid foundation on working with positive and negative numbers, you will have accomplished something. Okay. So addition of negative numbers, subtraction of negative numbers, multiplication of signed numbers, plus or minus numbers, division of signed numbers, and then we go into chapter 8 in your book, Introduction to Basic Statistics, and tables and graphs. When we get to statistics, I will refer you to an interesting book. The book is called How to Lie with Statistics. How to Lie with Statistics. The object will not be to teach you to lie, but to make you aware of how people are trying to manipulate what you see and try to get you a sense of seeing something that is not the way it is supposed to be. So it's an eye-opener. It's something that is useful for you to watch out for, not to get tricked or duped by numbers or by statements. It's a very easy to read booklet. It has about 100 pages. It is small format, a lot smaller than your textbook. It has pictures. It is in large print. You should be able to read it within just a few hours. It is extremely useful and it is amusing. If you can get a hold of it, it's published by Darrell Huff. Darrell Huff is the author. Darrell, D-A-R-R-E-L-L, Huff, H-U-F-F. So if you can try to get a hold of it before we do chapter 8 and maybe read how to lie with statistics, you will have a big advantage in chapter 8. And then we have chapter 11 left. We go to chapter 11 afterwards. And in chapter 11, we get introduced to geometry and how to work with some basic geometry. And then the area or the length and volume. And I think we will be finished. So there are 3 sections in chapter 11. Okay, I have shown you what you can look forward to. So go enjoy yourselves. I'll see you next time.